This presentation is about sustainable energy consumption and production. So basically, we're talking about both sides, energy consumption and energy production, and how we can make them more sustainable. First one is energy is really the foundation, one of the most important foundations of any modern society. As you can see that this is a satellite global map. So basically, if you have a lot of economy, if it's modern society, you can see that this place is very bright at night. If it is not very economic developed, then you can see that even though that some places may have a lot of people. For example, African continent, they have about 1 billion people, but you can see that this continent is largely dark. So as you can see that basically it's, without energy consumption, without a modern way of consuming energy, we cannot have a modern society. So this is really crucial to understand our perspectives of energy consumption and also supply. Energy consumption has, and also production has great impacts on the societies from many different aspects. So on the economy, of course, without modern energy consumption and supply, we just cannot have a modern economy. But another aspect is energy also has great impacts on the environment. And these days, this environmental impacts have been a driving force of its energy future. So what kind of energy we consume is largely decided by its energy's impacts on the environment. Example, so energy has great impacts on air pollution. If you see that this is a global map of PM 2.5 concentration levels. So it's most places, so it's PM 2.5 concentration cannot meet the WHO's long-term exposure limit. Basically, it's at 10 micrograms per cubic meter. At some places, so the impacts are even more severe, especially, for example, in North China and Northern India. When you have this, a lot of people living in one place, the economy is growing fast, but their mitigation may not be that fast enough to overcome the emissions from energy consumption. And so you can, so if you see that this map is changing every year. In the past, it used to start from Western Europe when you have this industrial revolution. Then they started to consume quite a substantial amount of coal, and this coal consumption led to very severe air pollution problems. And this one expanded to eastern part of the United States. So basically, when they have their industrial revolution, they started to have this impact. Now this one has been getting to Asia. So Asia is suffering from this very severe air pollution problems due to its energy consumption issues. Another one is these days, climate change is one of the most important topics in energy and also climate, and also in geopolitics. So this is the monitoring data from the CO2 concentration in Mauna Loa. So Mauna Loa is located in the middle of the Pacific. It's in Hawaii Island, the biggest island of Hawaii Islands. So over there, we can use this station's data to represent the entire Northern Hemisphere's average. So basically, we have reached 420 ppm. When this measurement started in 1958, we were about 315 parts per million or ppm. But today, so we are looking at 420 ppm, and this one has not been stopped, has no sign of stopping growing. So basically, we're going to face more and more severe climate change problems. And these climate change problems is mainly due to the consumption of fossil fuels. So because when we consume coal oil and natural gas, these technologies are carbon-based. So we convert carbon to carbon dioxide in this process, energy, chemical energy released, then we can harvest the energy for our consumption. But in this process, we made quite a substantial amount of carbon dioxide. So that is one of the major forces that are going to decide the future of energy consumption. So without which, for example, then we have, without this carbon dioxide concerns, then energy policy would be very different. And because of this, later on we'll talk more about it. So that's that's a key issue, that we have to reduce its emissions, but that's in the same process, and we have to go through the origin of the problem, which is the forced consumption of fossil fuels. So that's something we're going to tackle. And fossil fuels are also going to have another impact as well, as about water. So not every place is blessed with enough water resources. For example, in Hong Kong, we don't have enough freshwater resources. And but if you look at globally, these problems, and it's about water problems. So this energy sector is the largest, basically it's the largest industrial sector that is consuming water, consuming and withdrawing water, because especially for fossil fuel power stations. So this fossil fuel, when they generate electricity, they need cooling water. They need the cooling services, and this cooling is mainly done with water. So that's if we have consumption of a lot of fossil fuels, it means also we have to consume quite a substantial amount of water, and water problems also going to decide where you're going to locate this fossil fuel power station. If you don't have a lot of water, so you may have to constrain your fossil fuel consumption, or you may have to use another type of cooling technologies, dry cooling, to use much less water. But in that process, you're going to sacrifice some of the efficiency. So yeah, so with environment as one of the major concerns these days. So it's energy consumption and production putting great pressure on environments from many different aspects. So that's why we have to think about ways how we can deal with these problems. And so basically, how can we make our energy consumption and production more sustainable? So the first aspect is energy consumption. How can we make energy consumption more sustainable? First thing is you have to count that what is energy consumption? How do we count energy consumption? For example, and also it's because this one is also related closely to emissions. And so there was a lot of discussion about whose emissions, whose energy consumption that should be accounted for. And on climate change, there are three different kind of scopes. Scope one basically is saying that if you consume energy in your territory physically, then that's energy consumption is yours. Or emissions take place within your geographical territory, then that's your emissions. That's scope one emissions. Scope two emissions basically says that these two may be separated in space. For example, if you consume electricity, and so it's in the power stations, so they emit all of this carbon dioxide. But when you consume electricity, there's no emissions of carbon dioxide happening in your place. So it's then whose emissions that should be accounted for. In scope two emissions, that is counted as your emissions if you consume electricity. In scope one emissions, and it's not counted as your emissions because that emission does not happen, does not take place within your territory. So that is the difference between these two. So if you count our energy consumption, especially for coal power stations, or even natural gas power stations, so it's quite a lot of this energy actually is not within its electricity. It's actually as efficiency loss. In coal power stations, efficiency is about 40%. In natural gas power stations, the modern power plants, the efficiency is about 60%. So it's still quite substantial of energy has to be lost in the power stations. And in scope two emissions, for example, this one is counted as your emissions and consumption. And scope three is more complicated. Scope three is when you consume, for example, a product. Even though that, when you buy the product like a phone, so there's no emissions that's associated with the phone. So for example, with the phone itself, but in the production process of the phone, there are a lot of emissions that happened. And the scope three emissions means that that's counted as your emissions, or in this case, is energy consumption is down for you, for your service, to provide service to you, or this product as well. So in this process, so then, for example, Hong Kong, we have very little manufacturing here. So when we import all of these manufactured products, so if you talk about scope one, scope two emissions, that's not our emissions. But if you look at scope 3 emissions, that becomes all Hong Kong's emissions. So Hong Kong's scope 3 emissions are actually much greater than scope 1 and scope 2 emissions. So that's a difference. So then when we talk about sustainable energy consumption, then it really depends on which one you're talking about. If we're talking about only scope 1 emissions, so then we don't care about so energy, the embedded energy consumption that is consumed to produce the products that we consume here in Hong Kong. But if you look at scope 3 emissions, then actually if we conserve, if we don't use much this manufactured products, then that's also counted. That can also help reducing our energy consumption for the entire globe. So and all, if you count it as Hong Kong's scope 3 emissions. Then so it's basically energy conservation and efficiency is really important. So these are the energy labels for electric appliances. Not only we have to make our technologies better to make our energy services more efficient, but at the same time we have to change our behavior. So we have to use less energy. For example, we have to talk about the services. If we don't have to use the services, we may have to reduce the services that we unnecessarily use, and that can also save some energy. And also, so if you look at scope 3 emissions, that also means that we have to conserve the products that we consume. That can also help the entire globe conserve energy and reduce our emissions. Then, so if you look at this one, so not only so this one may not be entirely legitimate for the entire globe, because every place is so different. As we just saw, that the entire African continent is pretty dark. It means that they are living under very severe energy poverty. And you can see that from this one. So this is gives you some data about household electrification progress. So, for example, in 1920, this one says that in the United States, about 35% of the Americans already got electricity access. That was 100 years ago. And if you look at it, so this one is, so in China achieved this 35% in 1970. So basically China was about 50 years behind the United States. So this number was achieved in India. This ratio was achieved in India in 1985, basically. So it's even much later. So it's in Africa, that's this number is actually also much lower today. So basically, different countries are so different. When we say that we should do more to conserve our energy, it does not mean that we should reduce energy consumption for everybody on this planet. Because for those people who live under energy poverty, we want them to consume more energy to have better living standards. So in that way, we can address the energy poverty problems and also the poverty problems as well. So for energy conservation, especially for rich societies, for rich economies, so we should bear more responsibilities to reduce our consumption, and this way we can save more space in terms of emissions for those poor people and poor countries, to elevate the energy consumption levels and enjoy better modern society. And so that's energy consumption. So we should make it more sustainable. And also, but there's another aspect is so after we consume, so we have to consume energy. In the future, that we are expected to consume more and more energy. So even though that, so we should still try our best to conserve energy, but even in rich places, we expect it to consume more. And with this energy consumption defined, and we have to also make sure that our energy production is also sustainable. So in order to reduce our emissions, for example, so one of the major pathways to reduce our emissions is through electrification. We want more and more our energy consumption to be electrified, because currently for those non-electrified energy, mostly is done with the combustion of fossil fuels. And this combustion of fossil fuels is going to emit all the pollutants, and especially carbon dioxide. And so that is a major concern these days. So it's electrification, which means we can especially squeeze the space of combustion, for the fuel combustion. Then we can use other things to further decarbonize electricity. And if you look at this one, so this graph shows you the electrification rate currently in the United States in 2015. So basically, so in the commercial sectors and residential sectors, most of this energy consumption have already been electrified. So it's basically in buildings, we consume most of the energy in the form of electricity, but not in, especially in the transportation sector. In the transportation sector, most of the energy consumption is still in the form of direct combustion of gasoline, diesel, kerosene, or fuel oil. So we want to further electrify them so we can use other things, so other renewables, especially to decarbonize this one. And so electrification itself cannot solve our problems, cannot lead to the most sustainable energy consumption, cannot lead to the reduction of carbon dioxide emissions or this environmental impact, but it can give us a pathway to do further. So electrification must be met by decarbonization of electricity. So first one is we have to largely phase out fossil fuels. So as we saying that, in order to phase out fossil fuels, one of the ways is to electrify them, because then we can squeeze out the direct combustion of fossil fuels in a non-power sector. So this is Castle Peak Power Station in Hong Kong. It is one of the largest coal power stations in the world. So we want to phase them out in the future, and actually they are being phased out at this moment in Hong Kong. So in the future we will see less and less coal power stations. But the thing is, when Hong Kong is replacing its coal power stations, it's not going to get replaced with renewables. It's going to be replaced with natural gas power station. That's also not a kind of fossil fuel. It's also going to emit carbon dioxide. In future, we want to do a more fundamental reduction of carbon dioxide. So that means we have to get more renewables. And a renewable future is actually feasible. If you look at the map around the globe, we have plenty of renewables, wind energy and solar energy. This one shows you the global solar energy map, especially in the tropics and subtropics, basically. So we have quite substantial amount of solar energy. Even in the polar in the regions with high latitude, for example in Europe, we still have some solar PV panels that can be used. And so basically, so when we do the calculations, even though that we do recognize the distribution of solar energy is not even across the globe, but globally, for most countries, we can possibly rely on renewables for 100% of our energy, especially if you count with wind as well. For example, Europe, for Northern Europe, even though the solar energy may not be adequate, especially in the winter time, wind energy can also compensate quite a substantial amount of this lost solar power output in the winter. And so with all of this, we can achieve this 100% renewables, but of course, there is many challenges. So one of the challenges here is our renewables are very different from fossil fuel power stations. Because fossil fuel power stations, when they want electricity, they can generate electricity, regardless of when we want it, when we want the electricity. But for renewables, it's very different. For example, wind, sometimes wind blows, sometimes wind doesn't blow. So when wind blows, we can have electricity generated from wind turbines, but when wind stops blowing, so we can have trouble. Another bigger problem is solar. Solar energy is, we have even greater problem, especially at night. At night, there's no output of solar electricity at all because there's no sunlight. This one shows you the Kings Park in Hong Kong, so the solar radiation, especially the direct solar radiation. Direct solar radiation drops so sharply before sunset. So this is also going to raise a substantial amount of challenges to the electric system, and also when sun rises. So this one also going to give us quite a lot of challenges because solar started to kick in. So then you need to reduce output from this from fossil fuel power stations or from other power stations in the sun when sun rises, and you have to also ramp up very quickly when the sun sets. And so in this way, so in order to achieve 100% renewables, so we have the renewable energy future. So then we need a few other things. We have to address these two challenges at least. One is so to count the difference between day and night for solar energy, we need energy storage. We have to store energy during the day, and then we consume the energy, electricity during the night. So then that's a crucial. If we cannot do this, we cannot store enough energy and make it balanced between day and night, or between the time when wind blows or wind doesn't blow, then we cannot achieve 100% renewable future. So that's one challenge, and this challenge we have been in a much better position in this year, for example, compared with 10 or 15 years ago, because the battery technology has improved dramatically. Now we have much better technologies. So in terms of batteries, and the cost also much lower. So that's one. So there's one advantage to think about this solution. Second one is about transmission. So this transmission, for example, because if you look at this global map, so a lot of this, for example, a lot of this Chinese solar energy and wind energy actually located in the west. In western part of the country. In the United States, for example, solar energy is here, is in the south, wind energy is in the Midwest. So but so they're different. They're not distributed together with the population or the economy. So then you have to get long distance transmission lines, and these high voltage transmission lines are pretty expensive. Then if you cannot make sure that so these transmission lines are utilized fully, then the cost of transmission will be very high. But if you have this one, for example, have this intermittent renewables, so which means, so that if you simply rely on the solar energy, for example, in Western China to supply Eastern China, and at night, these transmission lines are not going to be used. So that's going to push up the cost of transmission, because you basically leave a very expensive infrastructure unused for quite large proportions of time. So again, so there's energy storage for this one. In order to make sure that this one works, so you also have to get energy storage to make sure that, for example, when you produce solar energy in Western China, so it can be stored, so the transmission lines can also be used at night to transmit electricity to eastern part of China. So basically, if you can address these problems in a technologically feasible way, and economically that's also should be acceptable, should not be very expensive, then you can achieve this. So anyway, with all of this, with all the impacts of energy, and if we can achieve conserve energy, address energy poverty, and also make sure that we have addressed our energy production, make it more sustainable, make it less carbon intensive. So in this way, we can achieve a much more a sustainable energy future in terms of its consumption and production. Thank you very much. I'll start with here.